In last class, we have studied relative refractive index, absolute refractive index ভিতরে সম্পর্ক, the relation between relative refractive index and absolute refractive index 1 mu 2 এটাকে কোড পড়িবা আমি refractive index when light propagates from first medium to second medium. This is called refractive index when light propagates from first medium to second medium. That is equal to V1 velocity in the first medium, velocity of light in the first medium by velocity of light in the second medium is equal to V1 by C. এটি সিটাকে সেটিং করা আছে V2 by C is equal to 1 by C by V1 all divided by 1 by C by V2. अच्छा ये देखो mu1 এটা কোন দিস ইজ এটি এমটি আছে কিছু নাই তার মানে এটা a mu1 which means this is the absolute refractive index because light propagates from air to the medium. The medium is named as 1 and it is clearly air. Nothing is written means it is air. Let's say this 1 is not here, this is, let's say, M. Any medium, this is M. M means refractive index of any medium and this is called absolute refractive index. তাহলে এইটি আমি দেখিবা আচ্ছা এইটা কোড লিখি পারিবা a mu m means air the velocity of light kete c by medium रे velocity of light से जो medium हो glass हो oil हो water हो any medium Vm ମୁଁ ବର୍ତ୍ତମାନ କ'ଣ କରୁଛି ଦେଖ here I am writing 1 that means a mu1 then it means E1 let's say I am writing here G here I have to write also G here I have to write also G that means air to glass velocity of air, velocity in air, velocity in glass of light. Let's say it is absolute refractive index of water. Then nothing is written here. That's why we call it is absolute, because the light propagates from air to water. According to definition, when light propagates from air or vacuum or free space to any subtle medium, then the refractive index is called absolute refractive index. So now this is the A mu W. So here I have to write velocity of light in air. How much it is? C. Then here I have to write VW. Means velocity of light in water. So now tell me, this is equal to 1 by, you see here, this is the formula of absolute refractive index, because it is C by V1. So now I can write this is mu 1, absolute refractive index of first medium, divided by 1 by mu 2. So now it is 1 by mu 1 into mu 2 by 1 is equal to mu 2 by mu 1. बहुत समय भूले जाए, बहुत समय भूले जाए कौन 1 mu 2 is equal to mu 1 by mu 2. Wrong, completely wrong. 1 mu 2 is equal to mu 2 by mu 1. तामने second medium रो refractive index divided by first medium रो refractive index. एटा absolute refractive index सेठी पे आपको कहली मु medium रो refractive index. एटा को कई बार उनी medium रो refractive index. ना एटा first medium रो refractive index, ना एटा second medium रो refractive index. जदि एटी को लिखबी G, एटी लिखबी W, ना ए refractive index टा glass रो, ना एटा water रो. किंतु एटी एटा refractive index of water, और एटा refractive index of glass. और ये दीटा देखो absolute refractive index. That particular water refractive index mu W, and particular glass refractive index mu G. That's why this is called absolute refractive index. But this is not a particular refractive index. It is relative refractive index, means one with respect to another. So now 1 mu 2, finally we got 1 mu 2 is equal to mu 2 by mu 1. You see, here 1 mu 2 can be expressed as refractive index when light propagates from first medium to second medium. But definition, we can say 1 mu 2 is called, or can be said, refractive index of second medium with respect to first medium. But it is my advice to you, 1 mu 2, you just remember refractive index when light propagates from first medium to second medium, when light propagates from first medium to second medium. It is better to remember like this. Relative refractive index of second medium with respect to first medium. No doubt, 1 mu 2 can be stated as refractive index of second medium with respect to first medium. But the problem is, when you remember this, the definition of 1 mu 2 is this, then sometimes you may do mistake while writing 1 mu 2 is equal to V1 by V2 or sin I by sin R. But if you remember refractive index when light propagates from first medium to second medium, then it will be easy. First medium to second medium. So what? So it will be, in first medium the velocity is V1, in second medium the velocity is V2. So it is V1 by V2. In first medium the angle is I. Maybe it is 30 degree, maybe it is 45 degree. So sin 30 degree divided by sin 45 degree. 30 degree is the angle of incidence in first medium. 45 degree is the angle of refraction in second medium. So it is easy to remember. Means tole je rahibo से एठी जो मीडियम थिबो से मीडियम रो केसेस गुडा कतरा रहइबो आ एठी जो मीडियम ता थिबो तार केसेस गुडा क ऊपर रहइबो लोवर रहइबो तेणु एमती मने रखिबो 1 mu 2 means refractive index when light propagates from first medium to second medium. Okay, एबे आमे जानिबा the conditions for deviation of path and no deviation of path. Write one mu two is equal to mu two by write condition for deviation of path. Firstly, case condition for no deviation of path. Case 1. Case 1. In case of case 1, definition of path. This is case 1. Okay. Let's say this is the interface. It is called the interface. It is now it is a medium, let's say glass medium or any other medium. Okay, this is the interface. The interface means the plane separating two mediums. So now let's say this is air, this is also first medium, this is glass, this is glass, this is the second medium. Okay, and this is air, this is first medium, this is glass, second medium. Draw a normal perpendicular to the plane. This is the plane. एपटटा हला ए प्लेन रो आर पटटा हला ग्लास. ओके, दिस इज द नॉर्मल. एई जगह ए नॉर्मल प्लेन को इंटरसेक्ट करछि. अच्छा, ए नॉर्मल प्लेन प्रति 90 डिग्री कोण करछि. मेक्स एंगल 90 डिग्री. ओके, अच्छा, लेट्स से along the normal what incident ray propagate कर. Source is somewhere else. The ray propagates from the source. The source is somewhere else. Straight away the ray propagates and strikes the refracting surface. एटा को कहती refracting surface. एटा को मध्य कहती interface. Interface. एटा को मध्य कहती refracting surface. refracting surface. refracting surface. एटा को कहती इंटरफेस, एटा को भी कहती रिफ्रैक्टिंग सरफेस. अच्छा, now the incident ray propagates along the normal and there is no deviation. There is no deviation of path. Straight away the ray propagates from one medium to another medium. But according to the law, Refraction means deviation of path. But here is no deviation of path. Okay. Then we have to go through the laws of refraction, whether this condition can be stated as refraction or not. Why not? Because there is no deviation of path. Right? Let me say why there is deviation of path. There is deviation of path because I is not equal to R. Either I is greater than R or R is greater than I. It depends on whether the light propagates from rarer medium to denser medium or denser medium to rarer medium. If I and R are not equal or not same, then how can we say that straight away the ray propagates? Can never propagates. Okay. But in this condition, the ray propagates straight away, making 0 degree with the normal. You see, this is the point of incidence. Now you see, एमिति जदि रेटा जाई थांता प्रोपागेट करी इंटरफेस बा रिफ्रैक्टिंग सरफेस रे से पॉइंट रे स्ट्राइक कर थांता नो डाउट ए एंगल टाको हमें आई कहि थांते एंगल ऑफ इंसिडेंस. अच्छा, किंतु इंसिडेंट रे प्रोपागेट करची अलोंग द नॉर्मल. तेनु एबे देखो एटा को दबाई दियो. You just press it up. The incident ray is being pressed. Now the ray coincides with the normal. So I became 0. Okay. In this case, I is equal to 0. In this case, I is equal to 0 according to laws of refraction. According to laws of refraction, 1 mu 2 is equal to sin I by sin R implies one mu 2 into sin R is equal to sin I. Here I is equal to 0 degree. Put it here. 1 mu 2 into sin R is equal to sin 0 implies 1 mu 2 into sin R is equal to sin 0 0 implies sin R is equal to 0 by 1 mu 2 implies sin R is equal to 0. implies sin r is equal to sin 0 cancels, r is equal to 0. We have taken I is equal to 0, that means incident angle is 0, and finally we got the refracted angle is also 0. So when incident angle is 0, the refracted angle is 0, and the incident angle is 0 at what case? At what condition? The incident ray became 0 when the ray propagates along the normal. So there is no deviation of path. This is case 1. Let's move to case 2. Condition for no deviation of path. Case 2. Case 2. Okay. Case 2. You see, this is air, right? Just imagine here is a plane separating both the mediums, and both the mediums are same. Let's say both the mediums are air. You may think, you may feel, how can it possible? An interface separating both the mediums, and both the mediums are air. Just imagine, here is an interface, and this particular imaginary interface separating the medium into two halves. This side is air and that side is air. If you are not convincing yourself, then let's say the first medium is glass. Okay, this is a glass. The first medium is glass. Okay, the second medium is also glass. Let's take two glass slabs and join it up. Let's take two glass slabs and join them. Okay, face to face. The common face is called interface. Okay, this side is glass, this side is also glass. The surface separating both the glass medium is called interface or refracting surface. Okay, and both the glass are of same color, same transparency. That's why the absolute refractive index of mu1 is equal to mu2. Means this is the absolute refractive index of first medium. This is the absolute refractive index of second medium. So now the first medium is glass. The second medium is also glass. Refractive index of first medium is mu1 and it is mu2. Both the mediums are made up of same glass. So mu1 is equal to mu2. Okay. Now we have to apply laws of refraction. According to laws of refraction, 1 mu2 is equal to sin I by sin I. Okay, let's say the interface or refracting surface in any way, means let's say not along the normal, okay, not along the normal, no, let's say the incident ray strike the interface at this particular point, and this is the point of incidence, theta. Now the ray propagates directly. There is no deviation. There is no deviation of path. That means this is the opposite angle. I is equal to R. How can it be possible? How can it possible? I is equal to R. In refraction, I is equal to R. How can it be possible? It is refraction as well. Incident angle is equal to refracted angle. How can it be possible? Yes, it is possible. If two mediums are same, then there will be no deviation. So 1 mu2 is equal to sin A by sin R. Okay. Implies this is relative refractive index. 1 mu2 is how much? Mu2 by mu1 is equal to sin I divided by sin I. Implies, you know, both the mediums, both the sides of the interface are made up of same material. That's why mu1 is equal to mu2. So mu2 is equal to mu1. Let's say mu1 is equal to mu2 is equal to mu. Put it here. Mu by mu, okay, is equal to sin I by sin R. Implies mu2 is equal to mu1. So how much will be mu2 by mu1? If the numerator is equal to the denominator, the numerator is equal to the denominator, then what will happen? This ratio will be 1. So it is 1 is equal to sin I by sin R. Sin R. So just cross multiply it. But remember, 1 mu2. Once again I am telling you, 1 mu2 is the relative refractive index, no doubt. But 1 mu2 is equal to mu1 by mu2. Wrong. 1 mu2 is equal to mu2 by mu1. Here you see, তলে আছে 2, এটি উপরে আছে 2, এটি উপরে আছে 1, এটি তলে আছে 1. So always remember 1 mu2 is equal to mu2 by mu1, not mu1 by mu2. But 1 mu2 is equal to sin I by sin R, is equal to v1 by v2, is equal to lambda 1 by lambda 2. but is equal to mu 2 by mu 1. So, in the numerator, always will be mu 2, and in the denominator, always it is mu 1. Okay. So now both are same. So just cross multiplied, it will be sin r is equal to sin I. Hence r is equal to I. That means refracted angle is equal to incident angle. There will be no deviation of path. So there is one case when there is no deviation of path, the incident ray propagates along the normal, and the normal is perpendicular to the refracting surface, right? That means incident ray drawn perpendicular to the refracting surface or interface, whatever may you can tell. Okay. Second case, there is also no deviation of path when both the mediums are made up of same substance, same material, and the material must be conducive, favorable for the propagation of light. Okay. So, condition for no deviation of path is over. Now, condition for deviation of path. This is case 1. Let's say here is an interface, okay? Let's say here is the interface, okay? The ray propagates from, you see, this side is a denser medium. Denser medium means ghana, not so transparent. Now you see, this is the interface or refracting surface. This is the refracting surface. The surface which separates both the mediums. Refracting surface. Refracting surface. Okay. Or you may say interface. Okay. Refracting surface, or you may say interface. Both the mediums are different, but which one is rarer and which one is denser? You see, the medium of this side is comparatively transparent than that side. So, rarer and denser generally used when there is a comparison between two media. So now, epoda medium tharu comparatively transparent. If you will compare this medium to that medium, this medium is more transparent than that. So that's why this medium is said to be rarer. Symbolically, I may write here R. This is the for R just, or you may write RARER, and here you may write DENSER, denser. So now this is the rarer medium, this is the denser medium. If we compare, this medium is more transparent than that. Okay. What will happen? In rarer medium, let's say this is the rarer medium, and you can name it as 1 and name this medium as 2. Okay. Now the ray propagates from rarer to denser. Okay. What will happen? Let's see. The ray strikes the interface, hits the interface at this point. This is the angle of incidence. एटा हला angle of incidence. एटा हला normal. अच्छा. तो वर्तमान ये रेटा जीवा कथा को बड़े. Actually जल्दी एटा straight जाए थांदा, ताहले एमिति. But the question is, ये condition for deviation of path. Then case one the condition for deviation of path. Okay, condition for deviation of path. तामाने path रे deviation हबो. Incident रे straight away जीवन नहीं. Never moves straight away. किंतु deviation हबो जे toward को हबो. Towards the normal or away from the normal. Normal आड़कू हबो ना normal ठू दूरे जीवो. এই জায়গাটা হলা point of incidence. দেখো করিয়া, we have to go through laws of refraction. अच्छा, 1 mu 2 is equal to v1 by v2. अच्छा, this is equation I, right? 1 mu 2 is equal to sin I by sin R. Okay, double I. So now combining both the equations, combining both the equations, we get sin I by sin R is equal to v1 by v2. But you know, in denser medium, the velocity of light will be reduced in rear compared to rarer medium. So V1, the velocity of light is here V1, the velocity of light in second medium is V2, and V1 is greater than V2. That means V1 is greater than V2. एपटे एटा स्वच्छ थिबारु लाइट रो बेग एपट साइड मीडियम रे अधिक एपट साइड थारु केवल स्वच्छता उपरे लाइट रो बेग निर्भर करे सेथि पई फर्स्ट मीडियम रेयर मीडियम है थिबारु V1 is greater than V2 कारण डेंसर मीडियम रे लाइट रो बेग रेयर मीडियम थारु कम था. That's why V2 is less than V1, which means V1 is greater than V2. Now you can say V1 is greater than V2. No doubt, sin I will be greater than sin A. If V1 greater than V2 implies sin I greater than sin R. So sin I is greater than sin R because V1 is greater than V2. V1 is the velocity of light in rarer medium, स्वच्छ medium रे, और V2 है la velocity of light in denser medium, माने comparatively अस्वच्छ medium. अच्छा. So V1 is greater than V2 means sin I is greater than sin R. So now cancel both the sides. What we will get? I is greater than R. Or you may say R is less than I. Tamane. Or you may say R is less than I. Tamane, the refracted ray bends towards the normal. So this is the angle of refraction. Okay, this is the angle of refraction. This is the normal. And this is the angle of refraction, this is the angle of incidence. And here, angle of incidence is greater than angle of refraction. Because the ray is propagating from rarer medium to denser medium. In case of the ray is propagating from denser medium to rarer medium. Reverse. It will reverse the condition here. What we got here? The ray bends away from the normal. The refracted ray bends away from the normal. If V1 is denser and V2 is rarer. When V1 is denser, V2 is, when first medium is denser, second medium is rarer, the ray propagates from first medium to second medium, from denser to rarer, the refracted ray bends away from the normal. Because in that case, sin I will be less than sin R because V1 is less than V2. So I is less than R means R is greater than I. That's why the refracted angle bends away from the normal, and that is the alternate case of case 1. That is case 2, when the ray propagates from denser medium to rarer medium. Okay, all the best. Meet you next.